These are the rules for drawing a project diagram. The first rule in drawing a project diagram is that the first node must always represent the start of the project, meaning that each activity that has no predecessor will always start at the starting node, which is node 1. The second rule is that at the end of the project diagram, there must be an end node, which means all activities must end at one ending node. The third rule is an activity can only be represented by only one arc in the network. Therefore, there can only be a single arrow which represents the activity between two nodes. The fourth rule, two nodes can only be connected by at most one arc, which is same as mentioned before. So in case there are two activities that are from the same starting node and end at the same ending node, it is necessary for us to add a dummy activity so that it does not violate rule 3 and 4. A dummy activity will have a dotted line, as you can see from the example here. Here we are going to try one of the examples for you to see clearly how this works. Firstly, we draw the starting node and the arrow to connect with the next node. On top of the arrow, we put activity. So for A, the duration is 3. Okay, so we put A equals to 3. Next, we continue with activity B. We are going to do the same as what we did for A. Activity B is a successor for activity A. So the duration is 4 and we are going to draw a line here with arrow, and then B equals to 4, so we put here B equals to 4. Okay, so we see here C, D, and E all have the same predecessor, which is B. So we have to draw 3 lines popping out of the end node for activity B, which will become the starting node for C, D, and E. So this is C. Another line for D. And the last line for E. Okay, so C has the duration of 5, so we're going to put C equals to 5. D is 7, so 7. And E equals to 4. E equals to 4. Okay. So now we look at F and G. Both are from the same predecessor, which is C, so the process is the same as what we did just now. Okay, we're going to draw 2 lines from here, another one here. End node, this is for F, and another end node, and this will be G. F, the duration is 8 and G is 6. Okay, now moving on to H. Unlike the activities we did before, it has more than one predecessor compared to the other. Before this, they only have one predecessors. H begins where F and G end. So let's look where F and G end. F ends here and G ends here. Now, if you remember from the rules that we have gone through before we started this example, only one node can accept one arrow that represents an activity. Like here, this one. So it cannot be like this. Let me show you. Okay, this is wrong. There cannot be two arrows showing one activity. So let's wrap this off first. To solve this problem, we have to draw a dummy activity. So dummy activity will have a dotted line like this. Then only we can draw H, the solid line, like as usual we did. Okay, this one is H and H is 9. So H equals to 9. Okay. Now we look at I. It also have more than one predecessor, but this time it has 3 activities preceding it. So, as we can see, I begins where D, E, and H end. So, D ends here and E ends here. This has the same concept as activity H above here. So we can add dummy activity right here with the dotted line. And another one here. Right. And then we draw the line for I, the solid line, with another end node. So I has the duration of 12. Alright. Now as you can see here, we have 2 dummies. We can tune either one of the dummy activity to connect directly from here to where H ends. So we rub this off. Okay, and draw a solid line here. Okay. D equals to 7. Okay, perfect. The reason is because if we look at the rules, 2 nodes can only be connected with at most 1 arc, which means can only be connected with 1 activity. It also means that no activity should have the same starting node and have the same end node. For H, the starting node is here and it ends here. For D and E, it starts here and only one of them can end where H ends. This is why either only one of D or E can be connected straight to where H ends, which is there. Okay, so now we have drawn I. The last activity will be J. Okay, this is the final node and the duration is 4. Okay, so now we can put the numbers on the node accordingly. So now we are calculating ET and LT. ET stands for earliest event time and LT stands for latest event time. So for the first node, the ET will always be 0. So ET equals to 0. For the next node, we take the previous ET and add the duration. So 0 plus 3 will be 3. Node 3 will be 3 plus 4 which is 7. 3 plus 4, 7. Node 4 would be 7 plus 5, 12. Now we check out for node 7. So 7 plus 4 equals to 11. For D, we're gonna ignore D first because there are prior nodes that we haven't solved yet. So 5 is 12 plus 8. That would be 20. For 6, since there are two prior nodes that are pointing to 6, we have to compare which one, when after added, will have the highest value. So 12 plus 6 would be 18. Node 5 will still be 20. Okay. We are going to choose 20 because since there are no duration for dummy activity. So 80 for node 6 will be 20. Okay. For node 8, we have to compare which one has the highest value from node 6, 3, and 7. So 20 plus 5 will be 21, 7 plus 7 will be 14, 11 plus 0 will be 11, so the highest will be 29. Okay. Then we just add the corresponding nodes. For 80 would be 41, and 41 plus 4 would be 45. Right. Now for the last node, the LT will always be the same as the ET. So it will also be 45 for J, and this is to get the LT for node 9. We have to minus 45 and the duration, so it will be 41. Okay. For node 8, we will get 29. And so does node 5. Okay. Now to find the LT for node 4, we have to compare the LT from node 5 and node 6, but they both have to subtract the duration of the preceding activity. So 20 minus 6 will be 14, 20 minus 8 will be 12, so LT will be 12. Right. For node 7, there are no duration for the dummy, so LT will still be 29. For deciding the LT for node 3, there are 3 nodes for us to consider: node 4, node 8, and node 7. So 12 minus 5 would be 7. 8 minus 7, 29 minus 7 would be 22, and 29 minus 4 would be 25. So the smallest is 12, so we put LT here equals 12. Wait, no. Their problem is supposed to be 7, so let me rub that off first. Sorry about that. So 7 and 7 as well. So LT for this would be 3, and LT for node 1 would be 0. Okay, there we go. So now we are trying to find the total float and the free float of the activities. so that we can know which activities that can be delayed without actually delaying the completion of the project. So let's start calculating. For activity A, to find the total float, we must take the LT of the second node minus the ET of the first node, and then we also have to minus the duration of the activity in between of the nodes. So 3 minus 0 minus 3 would be 0. For free float, we must take the ET of the second node, which is 3, minus with the ET of the first node, which is 0, and minus with duration, which is 3. So it will be 0. Okay, for activity B, we look at the third node and node 2. So LT is 7 minus ET of node 2, which is 3, you get 4, and then minus B, we get 0. For free float, the ET of node 3 minus ET of node 2 minus duration, and we will still get 0 as well. So we do this for all the corresponding nodes. We're finding for activity C, 12 minus 7 minus 5 will get 0. Same also for the free float. For D, 29 minus 7 minus 7, we will get 15. The value is same for the free float. So now we have completed the table. So now we can check the activities. The activities with 0 total float are the ones included in the critical path. So activity A, activity B, activity C, activity F, activity H, I, and J. So now we can know what is our critical path would be. Critical path, it starts from A to B to C to F to H, I, and lastly J. Okay, so in the diagram, the critical path will start from A to B to C to F, and then to H to I and J. Okay. Now we look at Program Evaluation and Review Technique PERT. PERT is used to estimate the probability that the project is able to finish under given deadline. So, given in the table is the optimistic time A, B, the pessimistic time, and C, the most likely value for the activity's duration. So the first step is to find the expected duration for the total activities in the critical path. So we know that the critical path is from A to B, C, F to H, I, and J. By using the formula of A plus 4M plus B divided by 6, we will get 3 plus 4 plus 5 plus 8, 9, and the total is 45. Next, we have to find the variance of the critical path by using the formula b minus a squared divided by 6 squared. And the total we will get is 3.08. After finding the variance, standard deviation can be calculated by square root the variance. And then we get 1.755. Finally, by using the standard deviation that we have calculated, we can find the probability. Let's say that the project is to be completed in 40 days. So we find the value of z by taking 40 minus the expected duration, 45, and divide with the standard deviation, 1.755, and we will get negative 2.85. Since z is in the negative value, we change it to positive by subtracting it from 1. And to get the value of z, we can refer the value from the normal distribution table, which we will get 0.9978. So 1 minus 0.9978 is 0.0022. The probability that the project will be completed in 40 days is 0.22%, which is very unlikely for the project to finish on time.